So now we have Ibrahim Bey. I hope I pronounced that reasonably well.
Absolutely perfect.
Good. And he is assistant professor and Cyprus. No, wait, I don't know where you are. You have been working at Cyprus International University and the European
I'm
University.
currently in European University of Lefke.
Yeah, good.
Yeah.
And you are working with the civil engineering, hydraulics, and been in several universities, coastal engineering, and you have been a Liverpudlian as well in the UK.
That's correct. Yes.
So
I was there for about 3.5 years for my PhD, and I think it was one of the most important mistakes of my life that I moved to London, and the whole life scenario actually has changed.
Yeah. And you will be talking about the general overview on water existence in lunar regolith. I'll be asking later if there is nitrogen there as well, but let's start with your presentation about water. The floor is yours.
Thank you very much. Let me share my screen and think. Is that good enough?
Yes, that's good.
Right. Thanks, Nicholas. And hi, everyone. Usually, we normally use phrases such as good morning, good afternoon, but being on the other side of the world, so I can't use these phrases that we are used to actually on face-to-face presentations. So I'm a bit confused. Maybe I should say good afternoon or good night, because it's about 10 o'clock here in Cyprus at night. So that's why I preferred using hello. And I definitely need to express my special gratitude to Professor Toklu, who invited me actually to work on this very interesting project, well, or research, let's say. So we started working recently, and since I have the background in hydraulics and civil engineering, that's why he invited me actually to work on existence of water and stuff. And I'm co-supervising one of his students actually, and so therefore we decided to move on with the availability of the water and its derivatives actually, as we need to use this source as mankind actually intend, or humankind, sorry, human being, not the mankind anymore. I need to be very sensitive, be careful on using these words. So we need to intend to travel more frequently to Moon, and if possible, actually to put some space stations or anything like that as shelters. So let's start talking about the presentation then. So this will be a general overview actually of the existing literature, whether we have the sources actually are available on the Moon or not. So this is very basic contents. So brief introductory, and then existence of lunar water, sources of lunar water, amounts, and the detection methods, and then locations of these to conclude. So we know that settlement outside the world has been a quite interesting topic for some of us, and as we need to use the water as the source of life, so therefore we need to find some sources of water on Moon as well, if we are interested in visiting there a lot. So it has been an interest for some engineers and scientists for the last few decades, and although in the, let's say, a couple of decades ago, we were thinking that there is no atmosphere, so therefore there shouldn't be any water and stuff, but recent studies are indicating that there are some sources of water, and they are either in hydroxyl or in waterized forms on the lunar surface, or regolith, areas. So under the insights of this water's presence, studies have focused on the amount, location, and extraction methods of the water on the moon. So the basic scope of the study actually is to scrutinize those studies were carried out by different scientists or engineers to focus and summarize the other studies. So, is water available on water? Is water available on the moon? So studies have shown that water actually in ice form, for example, has been found in the permanently shadowed region of the moon within the last few decades, and therefore, and also closer to the lunar poles as well. And permanently shadowed regions never receive any direct sunlight, so therefore, within these regions, within these locations, considering that the weather actually is extremely cold and allowing formation of water ice and existent stable states, but we are not sure actually how deep they are or how to make these sources available to be used by the end users or the human being. And NASA's Moon Mineralogy Mapper, M3, and the Lunar Reconnaissance Orbiter have provided some sort of evidences for the presence of water ice on the moon. And here is a summary table for the space research projects under different names and years and nations. So the Lunar Reconnaissance Orbiter have provided mapping for the distribution of water ice in the permanently shadowed regions at the lunar poles, which is quite important for us because we believe that the majority of the sources available on the moon actually are in this form, so in the water ice form. And Moon Mineralogy Mapper, that is an instrument actually aboard on the Chandrayaan-1 orbiter, identified some signs of water molecules on moon surface as well. And these sources of lunar water actually have been summarized on this table in different forms, in different subjects, under different subjects. For example, in primordial water or cometary impacts or solar wind implantations or micrometeorite bombardments, volcanic outgassing, and space weathering processes. These are the sources of, let's say, principles that generates the water molecules on moon. So therefore, if we can trace these water amounts or water sources, then we may start using these. So Jessica et al. Published a paper about hydrous mineral apatite in lunar highland samples, and also analysis of some most primordial in lunar samples show that the water these samples contain is characterized by H isotopic composition, similar to that of the Earth, and some carbonaceous chondrites. And also they have simulated for the impacts of the comets and asteroids on the lunar surface that have been done by Swetson and Chuvallo. So they studied and concluded that the impact of water-bearing carbonaceous asteroids could also deposit of free and chemically bound water inside some lunar craters as well. And they are yet, we are yet actually to define the amounts and locations of these sources. Solar winds are also bringing, as the previous presenter actually have mentioned, solar winds are also bringing some elements, so emanating from the sun and can interact with the lunar surface materials. So some hydrogen from solar wind can also be implanted into the lunar soil, which is called regolith. And over time, it can react with the oxygen-bearing minerals to form water. But this will take a lot of time, obviously. A chemical kinetic model that simulates the long-term evolution of the hydroxyl and/or water on the moon has been developed by Jones et al. In 2018. So Taylor mentioned about an experiment which can clearly show that the water can be produced on the lunar surface from the combination of implantation of solar wind hydrogen and thermal spikes caused by bombardment with the micrometeorite ice. And while the moon is generally considered dry, and some studies suggest that water vapor and other volatile compounds may be released during the volcanic activities, but this water actually could have been released from the lunar interior and contributed on the surface water content. And space weathering, obviously, which includes exposure to solar winds or cosmic rays and micrometeorite bombardments that can also alter surface properties of the moon. And some processes involved in space weathering could contribute to the formation of the water and hydroxyl on the lunar surface. So, as Ben has also mentioned, we're not sure about the amount of water, but some studies have also have already been studied as well, or published. So majority of the sources available actually are on the permanently shadowed regions, and some can be extracted from the lunar regolith, and spatial variability also available, and volatiles. And within the permanently shadowed regions, where temperatures are extremely low, are believed to host the significant amount of water in ice form. And Brown et al. Compiled some observations indicating the presence of volatiles from remotely sensed data sets in 65 different permanent shadow region locations for these amounts and their deposits. And within different craters, for example, they have studied to estimate the amounts of water, and they come up with the listed numbers, and these are in million, like 11 million metric tons. In the Cabeus or in the Shoemaker, for example, it's like 5 million metric tons. So it sounds like we have some amount of water on the permanently shadow regions based on these published papers, but we still need to do some more on defining or at least confirming the amounts of these water, so that we can start talking about different methods in extracting these water or bringing them into useful form. So water also is thought to be present in the form of hydroxyl and adsorbed water molecules within the lunar regolith. So the amount of the water in the regolith can vary across different regions, as Hegde et al. Has published. And NASA's Lunar Reconnaissance Orbiter suggests that the water ice may exist at varying depths below the lunar surface. And in addition to the water ice, volatile compounds such as hydroxyl have also been detected on the moon. So these compounds contribute to the overall inventory of the lunar volatiles. To detect these lunar water, and we know that scientists have different approaches, or they have their different ideas to detect the water on the moon. And these methods are designed to identify water in different forms, such as ice or hydrated minerals or adsorbed water. And following table shows us the different methods of detecting the lunar water, such as they have different scientists actually have studied, or engineers have studied different methods on defining the amount of water on the moon using spectroscopy or neutron spectroscopy, radar mapping, thermal analysis, mass spectrometry, or direct impact and sampling, and future drilling. If we need to briefly talk about the methods like reflectance spectroscopy, is like instruments like the Moon Mineralogy Mapper and on the Chandrayaan-1 spacecraft, and visible and infrared mapping spectrometer on Cassini spacecraft, use reflectance spectroscopy to study the absorption feature of minerals, including those associated with water and hydroxide. And Honeywell et al. Discussed a figure below that shows water abundance with respect to the latitude measured by SOFIA, which is Stratospheric Observatory for Infrared Astronomy, and M3, which is the Moon Mineralogy Mapper. So within this figure, actually, we have the abundances versus latitudes measured by SOFIA at 6 micrometer and M3 at 3 micrometer, like those dots, circle dots on the figure. 6 micrometer are shown by black dots, and the 3 micrometers are shown by the red ones. And the gray lines actually are the 1 sigma uncertainties in the M3 data. So they also consider the uncertainties as well. Neutron spectroscopy, it's like an instrument on the Lunar Prospector mission measured the flux of neutron emitted from the lunar surface, and variation in neutron flux can indicate the presence of hydrogen, which is associated with water. And radar mapping is another technique, is another method. Earth-based radar systems, such as Arecibo Observatory, have been used to transmit radar signals to the moon and analyze the reflected signals. And different papers actually have been published. And Thomson, for example, shows the interaction of radar waves with lunar surface can reveal the presence of water ice, or Campbell says the hypothesis that water ice is present near the poles was explored by the number of studies that used Earth-based ratio telescopes to create radar images of the moon, and SPUDIS, having shown that the 2 types of high circular polarization ratio features are found in the lunar poles in their analysis. So polar anomalous deposits are found in permanently shadowed region and are very... Thermal analysis is another method that we may consider, and on board NASA's Lunar Reconnaissance Orbiter and Diviner instrument measures the thermal emission from the lunar surface, and variations in the thermal characteristics can indicate the presence of water ice, and especially in the permanently shadowed regions. Study that has been done by Hibbets et al. Indicates that the thermal desorption curves of water from lunar samples, which are called JSC1A and Albight. So the curves on the figure on the left are indicating their results. So the curves indicate the relationship in between varying temperatures against the desorption rates, and figure above was plotted for JSC1A, and the one below shows the variations for Albight. Mass spectroscopy, spectrometry is another method, and it's an instrument like LIAISE, which is Lunar Exospheric Composition Experiment on the lunar atmosphere, and the Dust Environment Explorer mission analyzed the composition of the thin lunar exosphere, providing information about volatile compounds, including water. Direct impact and sampling, lunar crater observation and sensing satellites deliberately impacted a spent rocket stage into permanently shadowed crater, creating a plume of debris. The impact and subsequent analysis revealed the presence of water vapor and other compounds. So the next is about location of the lunar water. Lunar water have been found in various locations on the moon, and its distribution are not uniform. As we can see on the sample picture here, there are some traces in different colors, but they're not uniform, and following table shows that references for locations of lunar water, and as we can see, permanently shadowed regions, and that's probably the vast amount of water that we may find. And lunar regolith also may contain some amount of water, and volcanic deposits and sunlit regions, and exosphere and surface layers. And obviously we're talking about elemental analysis in the last two. So within the permanently shadowed regions, particularly the lunar poles, especially in the permanently shadowed regions, are considered primary locations for the presence of water in the ice form because of extremely cold regions. And instruments on spacecrafts such as NASA's Lunar Reconnaissance Orbiter and in India's Chandrayaan-1 have provided evidence of water ice in these permanently shadowed regions. And Shrobofer and Rufu supply maps of old permanently shadowed regions that can serve as a guide for the search of ice deposits that will soon be conducted by landed missions to the moon. Lunar regolith is also another source that we may bring some water out, and water is also present in the lunar regolith, the layer of the loose soil and rock covering the moon's surface. And this water, in the form of adsorbed water molecules and hydroxyl groups within the minerals of the regolith. So these hydrated minerals have been detected in various locations across the moon. And Etheridge and Kogler also conducted an experiment in which they used microwave to extract water from the lunar soil. Volcanic deposits. Some studies suggest that lunar volcanic deposits may also contain water, and volcanic activity on the moon could have released some water vapor and other volatile compounds. So therefore, if we can gather these together, contributing to overall water content. Sunlit regions, while water is more commonly found in permanently shadowed regions, some studies indicate the presence of small amounts of water molecules in sunlit regions as well. And this may also be present in thin layers of the lunar soil.
5 minutes left. 5 minutes left.
I'm almost done, it's okay. So exosphere and surface layers, as I have mentioned earlier, we may also have some traces or amounts of water that are available in vapor format. So therefore, this water actually is thought to be released from the lunar surface due to processes such as micrometeorite impacts and temperature fluctuations. And within the recent news, I am feeling a bit more excited actually, and would like to stay tuned for further exciting results. And if we have some opportunities, obviously, to make some extra research there, it will be very beneficial. And as I have mentioned earlier, since I'm from the hydraulics part of civil engineering, I should inform all the others that water is mine, and I'm not going to let anyone else using the water for other purposes rather than the use of the human being there, such as, because there are some other publications that we can extract this water to change its form and use the hydrogen inside the water amount and transfer it to the spacecrafts, for example, as a fuel and stuff. I believe that it should not be used, but we can use it. I mean, we can use the water for any other purposes rather than using for some other source of, let's say, energy. And that's it. On behalf of my team, I just would like to thank you for your attention. And if there is any question, I will be more than happy to try and answer.
Yeah, I think we have time for approximately one question. So Marufa just raised her hand. Please, Marufa.
Yes, thank you. That was a great presentation. So
Thank you
your
very much.
specialty is your specialty is more like locating the water. And my question would be, all the locations you already know, you already have some, NASA has some mapping and other private organizations.
Mhm.
How do you see yourself like using this water? Like at first, are we mining like water, extracting the water by mining? And then what are we doing astronauts when they're landing in those locations?
Well, since the beginning of this conference, actually, we kept listening about people commuting or trying to open up some spaces there, to create some spaces there, to start building up some living environment and stuff. So therefore, we'll definitely need some sort of shelters there. And either we need to carry all the goods from the world to the moon and build up our own environment there, or we can start using the sources available within the moon. And if we need to mix up any ingredients, let's say, or different materials, such as, let's say, concrete, so we need to use cement, aggregate, sand, and water. So we're desperate for water. So if we are trying to build up a shelter, so we will need some amount of water there, that's for sure. And I also have another special interest on adobe structures within the recent years, because I live in an island. I live in Turkish part of Cyprus anyway. So there are some traditional houses that are built by using the mud bricks or mud houses, let's say. So I have another special interest on that as well. So it's not necessary actually to use the traditions, but one way or another, if you're mixing clay with water to prepare that mud, you still need water. So we are not sure how the water actually will react with the regolith, for example, if it is mixed up with some other additives, but we still need water actually to construct our shelters. That's why I believe we need to use this water. And obviously, we are desperate to use water for sanitizing purposes. We are too far away from confirming whether it is, or it can be treated to be drinkable or anything like that. But
we do need to cut there. We have 30 minutes per presenter, and
okay.
we have passed that. So
okay.
thank you very much for the presentation. I have actually written a question in chat, so that if you can answer there, that would be good. Otherwise, we
Oh,
can
yeah.
we can talk later. That's fine too.
Okay,
Anyway,
to
I'll mute you now.